will call to the next speaker. The next speaker is Mrs. Pamela Tikku from ICAT. And she is a graduate in mechanical engineer from NIT, Jaipur, and she has been working in the automotive sector since 1992. She joined the Society of Automobile Manufacturers, SIAM, in 1999 and looked after various technical and policy issues related to the automotive sector in India. In 2006, she joined NATRIP and was involved in the planning and procurement of facility for testing and R&D to NATRIP Center. And in 2010, she took charge of the powertrain department of ICAT, one of the leading homologation centers in the country, in addition to the equipment planning and procurement activities under NATRIP. So, please, Mrs. Tikku, the floor is yours.
Thank you. I met you in GRP.
Okay.
Good afternoon, everybody. I would like to extend my thanks to Ben and team and teacher for giving me this opportunity to talk here amongst you and to talk about the buzzword in India, BS6 challenges and how to meet it. I guess since morning, a lot of you would have heard a lot of things about what are the challenges, what are we going to do it. But as Mr. Dave said rightly that, such challenges are good because the readiness happens quickly. A year back when people started talking about leapfrogging, it was absolute no-no. But within months, the leapfrogging from Euro 4, BS4 to BS6 has become reality. And industry is ready for it and gearing for it. So with this short introduction, I would like to go through my presentation. I would like to introduce, I am from ICAT, International Center for Automotive Technology, which is a center under NATRIP. This is a northern homologation center located in Manesar, approximately 35 kilometers from the Delhi airport. And we have full homologation, testing and development capabilities for all class of vehicles, whether it is two-wheelers, three-wheelers, four-wheelers, tractors, CVs, and many of you who are present here are our customers. This is the flow of presentation that I would like to go through. Introduction or to BS6, regulations at a glance for various class of vehicles, technology routes, probably it has been discussed a lot, fuel improvement technologies also I'll touch upon, key challenges in implementation, and the readiness in India in terms of testing, development and homologation from ICAT. So if you see any new regulation that comes for emissions, comes with a trade-off, whether it is regulatory requirement, the policy prescriptions, and the customer expectation. The policy expectation is reduction of targets, reduction of emissions, reduction of CO2 emissions, and the customer expectation is higher fuel economy, less noise, better drivability. So this is a conflict which any of the OEM has to face to strike a right balance between the two expectations. So in terms of engine development, there are inherent targets like trade-offs between engine and performance, emission and performance, and the kind of technology roadmap that needs to be adopted to enhance the fuel economy. So these are this is the development of emission regulations for heavy duty in India. I think most of you are aware of it. If you can see, we have basically leapfrogged from Euro 4 equivalent, which is BS4, to BS6, which is Euro 6 equivalent. And India decided to skip this intermediate step because this is what was felt will rear the benefits. The fuel quality is going to be same for both the regulations, the technological challenges are going to be slightly higher, but then it is going to be a one-time development from going from one BS4 to BS6. In passenger car also, if you see, this is the This is the emission regulations which are then envisaged for BS6. The new element that will be coming is PN numbers and this is the challenge area basically, how to reduce PM as well as PN number, PN regulations basically. In case of petrol CNG, the challenge is not so much basically. The biggest challenge is going to be diesel route of passenger car application. Here the the PM numbers have been included for the GDI technology. I guess many of the OEMs will move from the current technology of fuel injection system to GDI based technology, which brings into a new element called PM and PN. So that will be a challenge for diesel, for gasoline. As such, diesel is a challenge because of its cost and the technological integration of so many after-treatment devices which will be loaded on a vehicle. And on top of it, it is the Indian driving conditions which do not make these after-treatment devices, for example DEPF, to be easily adaptable in Indian conditions. In case of two-wheelers also, we have adopted a similar strategy in three-wheelers. The regulations which the two-wheelers will have will be equivalent to Euro 5 regulations. So for two-wheelers, it is, and also for three-wheelers, it is going to be quantum jump of technology, from carburetor technology. Now all the two-wheelers which are currently on road will have to move to fuel injection technology. And also the OBD has been introduced in two-wheelers as well as in three-wheelers. Although OBD in heavy duty and passenger cars have been introduced since 2014, but for this class of vehicle it is going to be a new element of challenge for the development. Another important character in the emissions worldwide has become RDE. So, there has been a lot of talk about Dieselgate and the role of RDE that has played in exposing the Dieselgate. Similar thing is being talked about in India. So, as a test agency, we tried to test our hands as to how we are going to implement RDE if BS6 regulations are going to come. Honestly speaking, it's not so easy. It has not been easy for Europe, I guess. It is not going to be easy for India. So it's a very, very important challenge which we'll have to face if we have to implement RDE both for passenger car. It's more difficult rather than as compared to heavy duty. PEMS based testing, the whole PEMS based testing has been developed basically with the perspective of Europe. The European driving conditions, the European climate, the European trip shares, and this is not actually suitable to be adapted as such for India. We have different speeds, we have different traffic mixes, we have different trip shares, we have different temperatures, we have different altitude. So this is going to be a real challenge when we are going to implement BS6 regulation PEMS based testing. Ministry of Road Transport has constituted a committee under Mr. Tyagi to evolve an India-based RDE testing. We did trials to see if we can do European testing in India. Honestly, the test after 32, 33 degrees of temperature did not happen. The test became void. The traffic conditions in Indian roads cannot allow us to follow the European RDE because there are lesser speeds, there is a more traffic density on the road, the stoppages are more, so it's very difficult, and we are a large country, the driving condition, the driving pattern, the traffic mixes in north, for example in Delhi is so different than in Pune, is so different than in Mumbai, is so different in Bangalore. So each city has a challenge, if you have to develop an India-based RDE, we don't know which route to emulate for executing that. So this is going to be a very difficult task, and already committee is working on it, how to evolve India-based RDE system. So two-wheeler RDE is still unknown. We don't know when it is going to come, but there is a discussion happening that we need to also monitor two-wheeler RDE. In fact, in Europe they do some, in US they do some trials on two-wheelers also to evaluate how the vehicle performs on road when negotiating the real conditions. In US and Europe, two-wheeler is not an issue because the population of these vehicles is very, very less. The density of these vehicles is very less in these countries. However, in India, if we see, almost 70% of the vehicles on road in major cities constitute two-wheelers, and they are big cause of concern. Basically, they emit a lot. The kind of fuel efficiency trade-offs that the two-wheelers are designed for. So it's very important to see how this particular element will impact the two-wheeler RDE if and when it happens. And for heavy duty, it is envisaged to happen from 2023. The procedures are under formulation, not yet started. In passenger car, the RDE monitoring is going to start from 2020, while the conformity factor will be implemented from 2023. So what are the technology routes? I guess this slide is quite familiar. Till Euro 4, we had basically these two technology routes. We had SCR based system and EGR based system. In case of heavy duty, it is going to be an after treatment which has DOC, DPF and SCR. Fuel injection system will have to be modified, and EGR will be there. So this is the kind of architecture that is being envisaged for heavy duty application in India. What the OEMs will do will depend on their individual strategies. In case of passenger car, it is more complex because in diesel there are a lot of permutation combinations that are possible. In BS4, we had basically DOC based after treatment system. In BS6, there are two possibilities, LNT, SCR and DPF. So what kind of architecture will be adopted will depend from OEM to OEM. Sorry. There are a lot of, there is also a CAFE standard which has been implemented from 1st April 2017 for passenger car application, and also there is a fuel efficiency standard under deliberation for heavy duty. So for improvement in fuel efficiency, there will be various technology areas which needs to be targeted. How the fuel consumption can be reduced, how to reduce the losses, how to reduce the frictional losses to enhance the fuel efficiency of the vehicle. So there will be ECU based software improvements, there will be smart engine and thermal management systems, smart accessories, engine measures and vehicle measures which will need to be undertaken for improvement of overall CO2 in the vehicle mix. So ECU based software functions in cylinder cutoff, start stop, cruise control, all these are envisaged to be implemented in BS6. Variable flow water pump, electronic control thermostats, variable speed oil pumps, electrical air compressors, electrical AC compressors, smart alternators, engine de-speeding, injection pressures are going to be higher, approximately 2000 to 2002 bar. EGR cooler efficiency will have to be enhanced and improved for overall efficiency improvement. Optimization in drivetrains, improvement in aerodynamics, tire pressure monitoring, all these are going to be considered because in India, these next 2 years are going to be very difficult and challenging especially for passenger car, because from 1st April 2018 we have crash regulations which enhances the vehicle weight. We also have a discussion of tire rolling resistance regulation under discussion that will be implemented. CAFE has been implemented and BS6 has been notified. So next 3 years are going to be very challenging for the auto industry to see what is the right mix of technology they are going to use to meet these targets. So leapfrogging, what is it going to lead to? Overall system cost will improve, will go higher actually. So in case of passenger car, up to $770 is expected. Heavy duty, it is 7,700. These are ballpark figures which have been estimated. The complexity of after treatment system is going to be high. There is going to be higher complication in after treatment devices because OBD algorithms and drivability and engine performance will have to be optimized and calibrated efficiently. Validation of after treatment system has to be done properly. RD for, as I said, for heavy duty and passenger car have a lot of challenges because it needs to be, now since if the RD has come, the authorities, for example, ICAT has an option to choose a vehicle and drive it in any part of the country on road, and that vehicle has to pass the regulation. So as I said, each place is a different drive conditions, each place. So the vehicle has to be designed for temperatures as high as 45 degrees, which happen in India, as low as it can go to minus temperatures in the northern part of the country. High humidities as high as 95% relative humidity, and as dry as absolutely 5 to 10% in desert area. So the variability of environmental conditions in India are large and huge. So the challenges for the auto industry to cater to all these conditions are becoming difficult and complex. So in terms of the readiness for testing and developing vehicles, what ICAT can offer and what ICAT can do is that we have a full-fledged engine test facility. We have 13 engine dynamometers. We have 2 eddy current dynamometers and 11 transient dynamometers, all equipped with emission system up to Euro 6 compliant. We also have capability of altitude simulation, thermal shock. We have ammonia slip measurement using FTIR technologies. We also have PN counters in our facilities and pre and post emission measurement system. So we can cater to BS6, Euro 6 level of automotive testing for construction equipment, tractor and power trillers, TREM 3 and TREM 3A. Also we can do EPA smoke test of 40 CFR, tractor PTO testing. We can do genset testing up to CPCB 2 level, FTP. So our transient dynamometer capacities in terms of eddy current is from 35 kilowatt to 200 kilowatt. In transient dynamometer, our engine dyno capacities start from 300 kilowatt to 800 kilowatt. So we are the first in the country to have a transient dynamometer of 800 kilowatt capacity with emission capabilities. We also have a lot of equipments for undertaking functional development tests. For example, lubrication system, breather system, cooling system, temp plug measurement, torsional vibration, piston bore interface, frictional analysis, resonance and NVH measurement, stress measurement. So all those test rigs which are used for development are available in-house, and we can help people to undertake the testing. We also have a climatic test cell wherein we can simulate from minus 30 to plus 50 degree temperature, and we can do cold startability tests for various range of temperature conditions. In our chassis lab, we have 5 emission chassis dynamometers for BS6 capability. We have, out of these 5, we have 2 4x4 4-wheel drive chassis dynamometer. All the chassis dynamometers for emission lab are equipped with emission capability up to Euro 6. We have PN counter, pre-post measurement. We also have a climatic chassis lab wherein we can simulate minus 30 to plus degree, 55 degrees. We can also do solar sun simulation. We can do AC performance test in this lab. We also can facilitate after treatment development with the use of pre and post emission system. We have 3 dedicated mileage equipment system wherein you can do durability using automatic robo systems. So you can do validation trial with these facilities at ICAT. We do a lot of oil and additive assessment because a lot of oil and additives are being added to the fuel and the engine to enhance the fuel efficiency and reduction of emissions. So these are the equipments I talked about. In terms of the capability, it is state-of-the-art facility in the country. It is comparable to any global facilities that one can find. And the facilities have been benchmarked with some of the leading OEM labs globally, and the consistency of these labs have been adequately established. Both European, Japanese and American OEMs have done the consistency trials with us. So we support in terms of certification, we support in terms of durability and validation, functional development, engine test bed development, calibration for OBD2, vehicle drivability and emission calibration, climatic calibration, ECU development. We also have an infotronics lab which has HIL system and models both for powertrain as well as vehicle models, which can be used for development of ECUs for different applications. We can do fleet validation and any specific test that an OEM comes up with, any challenging test, we are able to undertake it. So the flexibility of operation is quite great. So with this, I end my presentation on what ICAT is, how ICAT can support industry in development of BS6 or next stage emission regulations for two-wheelers, three-wheelers, passenger cars, heavy duty, gensets, off-road, construction equipment, tractors, etc. Thank you.
Thank you, Ms. Tikku. The floor is open for questions for any clarification, any comments that you would like to bring to the table.
My name is Rajendra Singh from Mahindra. Do you have the high altitude test facilities?
For engine?
Yeah.
For engine, we have a high altitude up to 2000 meters capability, but we are going to install a high altitude capability for engine test bed up to 5000 meters by the end of this year, by the end of this financial year.
Okay. Can you just comment on based upon the data, what happens when we go from 500 meter to 2000, like you said, 2000? Do you have any? I mean how much power reduction will
I don't
happen?
have the data because we have not done the test yet, but I do know that there is a reduction in power because as you go from lower altitude to higher altitude, the air becomes much rarer, and hence there is a drop in the power. So I really cannot tell you any quantified data that we have not done the testing as of now.
Yeah, myself Ayyappa Das from Mahindra. Regarding your test bed facility, what is the minimum ambient temperature, whether I can do the emission in your test lab?
So what minimum temperature are you asking for?
It's around 0 degree or 5 degree in that.
No, we don't have the emission engine test bed with minus degree temperature facility.
You are having a cold chamber.
We are having a cold chamber only for cold startability, not for emissions.
And one more question, whether blow-by gas emission can be measured at your end?
Yeah, we have a blow-by measurement system.
Not blow-by gas emission measurement.
I don't know what you mean by that. I mean, what kind of equipment?
Because in the norms, whatever for tractor also, they are saying blow-by has to be, either it has to be given to engine, else it has to be, emission has to be measured from the blow-by.
Okay.
So emission, they said that we can't measure it by putting exhaust. They have to measure it separately to this one.
No, we don't have that yet.
Okay, thank you.
One question to Dr. Delfo. What type of challenges have you faced while using the DPF technology particularly, and how you have eliminated? Can you just say something on that?
Well, the use of DPF is on or off. Either the DPF is operative or it is not. So we have not seen any large problem in that. If you do any measurements of particulate, you see a very fast increase in particulate number if the DPF is either cracked or is not operative. So it's not, it's most challenging to see what happened with SCR, because SCR is a chemical, let's say, lab on board. However, the DPF is just something very, let's say, that doesn't do anything, just stay there and filter. So the DPF is operative. You see that you don't have, or you have a very low PM number measurements, and PM as well, mass. And if there is crack above certain values, then you see a very sharp increase, and then you can say that the DPF is not working. A different matter is to create an OBD that can check the DPF. We have tried that in Europe. We have tried that with several technology that wanted to be able to operate, to be able to give the signal to the OBD that the DPF is not operating properly, and we didn't find anyone that was free of positive, negative, or negative, positive. So at this moment, the OBD is not looking into the DPF. It's only looking to the NOx and other pollutant emissions. We're still working on it, and we hope that in very near future we can introduce the particle inside of OBD. So, but returning to your question, is challenges with the DPF, we have not faced any.
Okay, thank you.
Yeah, okay, you have the macro, so you are the owner.
No, I must say it was quite an interesting presentation, and you raised some issues in terms of the RDE testing and how it fails in India. I do have a question. Maybe I'm standing on or pushing your personal or professional experience in this question. See how it varies from city to city, the parameters and the driving conditions. Do you suggest that India has her own city-to-city standard, or what would you say would be the best way for us to move forward?
In terms of RD, you are asking, how we are going to go about with how different city cycles we can have, right?
Well, in your opinion, do you think, because the driving conditions vary so greatly from city to city, from north to south, and from season to season, do you think India needs a city-to-city standard?
It's not possible to have a city-to-city standard. We will have to develop a standard driving cycle based on the data that we can collect from different cities. Already that data has been collected while developing WLTP. So India has collected data from different cities, seen the different parameters which has gone into as an input from India to WLTC. So that information is already there. So based on the different cities' data, which we already have, we may evolve at an RDE cycle for Indian application. It's very difficult to have city-based cycle, and then that means the vehicle manufacturer will have to calibrate the vehicle for so many cities. I mean, there are 55 mega cities in the country. It's not possible to do that. So we'll have to come up with an optimum cycle which is representative of most of the Indian conditions, basically.
Hi, good afternoon, ma'am. My name is Himanshu Kumar from New Holland Tractors. I've seen that your presentation has focused upon the BS6 emission norms, which will be coming in April 2020. And since we are from off-road application, and we also see that in the same year, October 2020, the Tier 4 or TREM 4 would be coming for agriculture as well as for off-highway, CEV engines and vehicles. So we expect that at that time there would be a flood of the engines or the vehicles that would be needed to be homologated as per the new norms, considering all the manufacturers would be in a hurry for that.
It is, you see.
So how, okay, my question was that how is your readiness or how is your plan to cater to all these requirements that would come to you at that time? Because no manufacturer would like to lose his market trying to get in delay on the homologation front.
So when BS4 was introduced, for example, for automotive, TREM 3 was introduced. At that time, ICAT had only 3 engine test cells. We have currently 13 engine test cells. And if there is a demand, we have another 7 test cells ready for installation of dynamometers and, for emission. So we are ready for any surge in the demand. So currently, our 13 transient dynamometers that we have installed, we are running at 1.5 hour shift. So we have a capacity to go up to 3 shift based operation, and also we have 7 test cells which are ready with bed plates, with test cell construction, all utilities. All you need is 3.5 to 4 months time to have dyno and emission system in place.
Okay.
So we are ready. The question that you're asking, that the moment we find that there is a peak load which is beyond our capacity, we can quickly generate that capacity.
Okay. Thank you.
Any other question or comment? If not, let me just make a comment and ask your thoughts on that, and then a question as well. The comment is, I have been hearing on the last 2 days how difficult it is to come up with a RD cycle in the Indian conditions, because Indian is of course different than Europe, and that there is a large variability in India. But I just look into Europe, and in Europe we have temperature-wise a large variability. We can go from minus whatever in Sweden to plus 45 in southern Spain or southern Italy. So yes, it's different, but the question is why we are putting that stress in the difference, first. And secondly is the driving, let's say, behavior of a Napolitan, people from Naples, is nothing to do with the driving behavior or even the driving environment that a person from Oslo. And still we were able to get something there. So therefore, are we just stressing too much the difficulty rather than try to find a solution? And that's a thought and a question. And I will get a second question after that.
Thank you. A very valid question, actually. Everybody raises this question the moment we say we need to do something differently. First and foremost, our speed limits on the highways is 80 kilometers, and in some stretches 90 kilometers, right? In Europe, your speed limits are?
Depending on the country, 120 or 130.
So that's one difference. So we cannot meet those speeds and those trip shares on highways. I don't know whether you had a chance to visit Indian cities.
Yes, I did Delhi, and it was a challenge.
Which part of Delhi? So which part of Delhi was
Oh, the center of Delhi is challenge.
Delhi. So in central Delhi, you would have seen small cycle rickshaws, which are mowed by people. You would have seen now electric rickshaws, which are mowed by people. You would have seen auto rickshaws. You would have seen sometimes bullock carts also, camel carts also. Tractors come on road. Then trucks, buses, all kinds of architecture. I don't think that variability of traffic you have in Europe, right?
Well, go to Naples and you tell me. Anyway.
Okay, so that is one. So secondly is, the temperature ranges that you talked of. In India, almost, I think, barring for 2 months, 2 or 3 months in Delhi region, Delhi and above, the temperatures are below 30 degrees. Only 2 to 3 months. Rest of the country, almost 70%, 75% of the country, the temperatures throughout the year are 35 and above. So those are ambient temperatures. So when you put a PEMS in a car, and even if the ambient temperatures are 35, the temperature inside the car becomes 40, 42, and the PEMS stops working.
You have to provide the right cooling. But anyways, my other question, thank you for the answer. My other question is more trying to know it myself. Both in the EU and in the US, the CO2 compliant targets, so how many grams per kilometer or whatever it is, in different dates are done by modeling in the heavy duty. In Europe we have the vector, in the States it has, I cannot remember the name now. How is India trying or is going to do any CO2 standard?
Heavy duty?
For heavy duty, yes.
Heavy duty, there has been a debate going on for last 3 years. There was a discussion to go on a vector-based fuel efficiency standard, but that has not been accepted, adapted. So it's basically BSFC-based standard which is under formulation. So that's the current scenario, but there is a roadmap to go to a much more scientific method of defining the fuel efficiency standard for heavy duty. For passenger car, we have adopted a similar way of fuel efficiency standard as has been done in Europe. Based on the current fuel efficiency, corporate average of the industry and the manufacturer and weight class base. So the CO2 limit has been defined for implementation from 1st April 2017, and next is from 2023.
Thank you.